Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous lecture we started our discussion and exercises in Python. So, let us go back to the same thing. So, as we understood the installation aspect, how to launch Jupyter Notebook and various other related things with the Jupyter Notebook in previous lectures. So, let us get started from where we left in the previous lecture. So, let us open our this file session Python basics, and in previous lecture we had gone through some of the basic functionality about Python. So, we will do a recap of that and then move on. So, some of the things that I wanted to make you familiar with is like loading required library modules. As you can see in the first line, we talked about NumPy and how it can be loaded. Import NumPy as NP. As NP is just indicating that we can load any module, any library module with a different name. So, there is going to be original name like NumPy, and then we can load it using a different name, shorter name like NP. So, after that typically we would like to set certain parameters as we discussed in the previous lecture as well. So, let us just go through this. So, let us run this. Now, we have gone through this first line of Python code hello world thing. So, I am just going through this variable creation, type completion, this aspect we have looked at, and then we looked at further type completion features, other type completion features where we use the dot thing. Then to seek info about an object, so how to use this question mark operator. So, this we have gone through in the previous lecture. So, I am just running through this and writing a function. So, though we would be later on doing more about this, but to familiarize you with this, let us go through this whatever we discussed in the previous lecture. If you want to display the source code, for example this one, you can see here source. So, this part we have discussed in the previous lecture. Now, if you want to search the namespace, so this is how it can be done. Let us move forward. Now, we talked about magic commands as such, ls magic, which will display you the available line magics and cell magics as we have discussed before. Some of the magic commands we learned to use in the previous lecture. For example, if we want to find out our current working directory, you can see here percentage the operator, and then pwd, it will help us print out the current working directory. Then if you want to list all the files and folders, so percentage ls is the magic command here. So, we can just run this, and whatever is present in the working directory, that is going to be displayed as you can see here. Now, if you have a separate file as a Python script, so how we can run that Jupyter notebook. So, that also we can see percentage run and the name of the file. So, you can see this is line magic, where arguments required for that command to be executed or also passed in line. In the cell magic, the any following is the lines of code would also be executed. So, that being the difference. So, let us run this. So, once we run this particular piece of code, this Python script. So, there we have defined a function f and a few variables a, b, c. So, we want to just access those variables and find out what are the values stored there. We can immediately see that we had also invoked make a function call in that script. So, result is the returned variable for the return value to store the return value. So, that we can again execute and find out. So, all these things we had discussed in more detail, slightly more detail in the previous lecture. Similarly, if you want to load a script into a cell, So we can use this magic command percentage load and then the name of the script. Here you can see that this is the output that we had executed in the previous lecture. So let us skip this and let us move forward. Then we stopped at this point in the previous lecture. Now the next thing that we would like to discuss is about integration of data visualization tools in Python and in the Jupyter Notebook platform. So we talked about a particular library module, that is matplotlib. So how that can be integrated, how the different functions and methods available in that particular library module can be accessed here. So we need to use this magic command here, percentage matplotlib and the space inline. So this is slightly different from what you might have to execute in IPython shell, but this will work for Jupyter Notebook. So let us execute this. So once we run this, now another thing that we can do is that there are different within that module there are going to be different modules as well. So that we can import, for example, matplotlib.pyplot. So that we can import with a different name PLT. So let us run this one also. So within this module there are going to be a number of functions that we can access. So one of them is like plt.plot, and where we can pass on this argument, which is again a function np.random.random, and we are passing 50. So we would like to create 50 random 50 random values, and then dot comes from, then we would like to compute the cumulative sum of those values, and because we are passing all these values into the plt.plot function, so those are going to be plotted. So in one go this particular piece of code is going to be executed. So let us run this. So you can see this plot is generated, and internally what I was explaining you, if you want to break it down to smaller steps, so this is also something that I have done here. You can see I am calling here np.random.random and 50 values I want, 50 random values I want. So if I just run this, I will get these 50 values, and if I want the cumulative sum of cumulative pattern of these values, so again I can run in this fashion. How the syntax is working and the specific language semantics and programming constructs in Python, we would be discussing as we go along this lecture and coming lectures as well. So as you can see that what I have done, first you can see 50 random values have been generated, and then the cumulative sum of those 50 values, as you can see in the output. So that same thing was actually plotted there. So let us move forward. Now we will start our discussion on the essential programming concept, programming constructs that are available in the Python, and the language mechanics as well. So let us start. So first thing is about how the code is to be written, and how Python is going to be different from something that you might have learned in other programming languages. In terms of different types of languages that we have talked about, the compiled programming language and the interpreted programming languages. So Python is the interpreted programming language, and typically you might be more familiar with the compiled programming language. So there is going to be slight differences when it comes to Python. So first thing, indentation there. In this programming language Python, we do not use braces, rather we use white space which includes tabs and spaces. So these white space is actually used to structure the code instead of braces, as is typically done in compiled programming languages. So a small piece of code that I have written to explain the same thing. You can see a for loop is written there, and you can see that the first statement for x in array here, and that is very clearly stopped at colon is being used to denote the start of an indented code block, and then we have the conditional statement if, and again you have the colon because another indented block code block is going to be started, and then we have else and then colon, and then another indented code block is going to be starting. So, colon is used to denote the start of an indented code block, and white spaces are typically used to structure the code instead of braces. So, you can see when we look at the line for x in array and the colon, then the next line is after one tab, that is 4 spaces. Similarly, when we when we have another colon at the end of if statement, then again one more tab is used to indent the next coming block. So, in this fashion indentation is done, and braces are not used, as you might be familiar with in other programming languages. So, let us run this. So, first we are creating this list named as array here, and then pivot is another variable, and then we have less and greater to empty list here, and then we are running a loop where for every object that is present in this list named array, and then we run then we compare that particular value, that particular element x from the pivot value. If it is less than that, then we append that particular element in the less list, otherwise we append that element in the greater list. So, let us run this block. So, you can see less after that we come to the next one. So, let us find out the value of less, that is 1 2 3 4, and the value of greater list, that is 5 6 7 8 9. So, the starting list was having all these 9 values, and because all the values which are less than 5 have gone to less list, and all the values which are equal to or greater than 5 have gone to the greater list. So, this example was mainly to tell you how the structuring of the code, how indentation is done, just to display that particular aspect of Python. Now, another important difference with other languages, mainly compiled programming languages, is that semicolon, usage of semicolon. So, in this case in Python, semicolon is actually used to separate multiple statements which might be present in the single line instead of termination of a statement. In many compiled programming language, semicolon is used to terminate the statement. Here that is being used as a separator. So, you can see we have this example, this line of code where we have a is being assigned the value of 5. So, a equal to 5, then semicolon to separate it from the next line, next statement which is written in the same line, that is b equal to 6, and then again semicolon, that is to separate this these two statements with the another statement that is also written in the same line of code, that is c equal to 7.5. So, we run this block. So, all these variables objects are going to be created and these values are going to be assigned. Now, let us move forward. Let us discuss a bit about a Python object. So, as far as any number, string, data structure, function, module, pretty much anything that we create in Python environment, that is considered by the Python interpreter as an object, and it is like that object is like its own box, and referred as Python object, and it could be anything starting from number, string, as I said, data structure, function, class, and all those things. And each object is going to have its own associated type. So, it could be integer or string. So, those types are also going to be there, and internal data. So, it will have its own type and also internal data. When it comes to creating comment section in Python programming language, typically hash mark, as you can see here, the pound sign here, this is typically used to add comments, and also sometimes we would like to exclude certain code of blocks which we might have written for certain experimentation purposes, and we might not like to execute that part of the code. So, we would like to comment that out. So, there also hash could be used. So, typically comments that are preceding a particular line of code, they are typically written to for explanation purposes, to explain what we are going to code next, how we plan to code next few lines, next few statements, to explain that part. And typically when you see a comment after a line of code, that is typically used for debugging purposes. So these are two main in a way practices that are being followed in terms of creating comment section. So that is common across programming language, same is the case in Python. So here you can see one line of code I have written print reached this line, and then after that that statement we have this hash symbol status report, that is mainly for debugging purposes. So this is why I have it here. And to explain all this that I am discussing, I have a number of comment section before this line of code. So that is typically for, as I said, for explanatory purposes. So let us run this. Now next thing that we would like to discuss is function and object method calls. So here let us understand function call when it is being when the function is being called without any arguments, or no return value is going to be there. So no return value assignment is required. So how that is done? So you can see we use this keyword def to define a function, and then name of the function, and then the parenthesis to indicate that this is a function, and then again this is also ended by a colon, which will again, as we have discussed, will indicate the start of the intended code of block of code. So you can see def for defining g function, parenthesis and colon, and then we have just one line of code, that is print function with no arguments, and then we are calling this function g. So if we run this code, we will get this as our printed output. Now if we want to make a function call which requires us to pass on the arguments, and we might also have a return value which is then will be assigned. So for example, we have this function f that we have defined previously. So we pass on these arguments a, b, c, and that whatever under functionality is present in this function definition, f definition, that is going to be processed, that is going to be executed, and the return value is going to be assigned to the result variable. So let us run this, and you can see the next line was result itself. So we got in the output the 1.46 the value that is there. Let us move forward. Now then there is another case, there is another thing called methods, which is function attached with objects. So function which are attached with objects are typically referred as methods in Python, and they will have access to objects internal data. So any processing, any computation, any steps that computational steps that you want to perform, that you want to execute, the methods will have access to that data, and it would be easily accessed and done. So for example, we had created a less list there. So if we want to call this method, append, so we can just write like this, less dot append. There are going to be other methods available which can also be used and which can also work on this particular type less, which is a list. And in this case what we are doing is we are adding this pivot value into this list. So we are calling like this, less dot append and pivot. So earlier, as you might remember, that less this particular list less had just 4 elements, 1 2 3 4. Now in the output you would see that another element will get added, that is 5, because pivot value was 5. Now there is another aspect related to arguments, that is there are 2 types, positional arguments and the keyword arguments. So whenever we are defining a function, so there are each argument has its position clearly embarked, So first argument, so whatever we want to pass and its first argument is to be written first, is to be typed first, and then second argument, and then third argument. Then there are keyword arguments where the keyword is used and a value is assigned, and that value is going to be the value for that keyword inside the steps that are going to be executed within the functional scope. So these keyword arguments might not have a fixed position, so they are to be identified by function with their name. So you can see here we are writing a function h. So again to define the function h, we need def h, and first argument is positional argument, which is x, then second argument is a positional argument y, and then the third argument is a positional argument z. So all these three arguments, they have to be in that order. So whatever we are passing as x or y or z, they have to be passed in those positions, position 1, 2 and 3. Then we have keyword arguments w, which is, you can see, equal operator is being used. It is being assigned the value of 9, so w is equal to 9. And then we have another keyword argument t, it is being assigned a string ohm. These 5 arguments that we are using to define this function, and within the body of this function we have just one line of code where we are printing this first t which is a string type object, and then we are doing this computation in the next object, that is x plus y plus z, first 3 arguments which are positional argument, and some of those 3 arguments is being divided by w, the fourth keyword based argument. Now we can call this function like this. We are calling h, and within the parentheses we have a, b, c, first 3 argument which are positional argument, they have to be specified in that order itself. Then w is equal to 5 and t is equal to we are passing a different value for w, and we are passing a different string for t. If we don't pass these values, then the default values are going to be taken. So let us execute this. So you can see Omkar is printed and a value is also computed. Now in the next example you can see I'm calling this particular function differently. Here you can see I'm calling h, and within parentheses I have a, b and c, and then I have reversed the order of t keyword argument and w keyword argument, and you will see we will still get the same output because other things remain same. Let us move forward. So now let us discuss variable assignments and argument passing. So how variable assignment takes place in Python and how argument are to be passed. So some aspects related to these two things. So whenever we create a variable and that variable might be assigned to another variable, both these variables will start referring to the same object. So in R this is one difference where once we don't create a different copy of a variable. When a variable is assigned to another variable, a new copy is not created, rather both the variables start referring to the same objects. So in a sense variables are just names for objects within a particular namespace. So whatever scope of namespace is there, in that they are just different names for the same object. So for example we had earlier created v1 and v2, and now if we run this block, so we are assigning v1 to v2, and if we just run v2, then you can see it is having these values 1, 2, 3 which were originally created with v1. Now if you want to test this particular test this particular aspect again, so this is another way. So what we can do is we can add another element, append another element in this list. So what we are doing is v1 dot append, and we are adding element with value 4. So let us run this, and instead of printing v1 we are printing v2 here. So if we print v2, so let us see, and you can see 1, 2, 3, 4 that value which was actually appended with v1, is also part of V2, because both of them are referring to the same object. Let us move forward. So, now another important aspect of passing objects to arguments as arguments to a function that we will like to discuss. So, whenever we are passing whenever we are passing objects as argument to a function, within the functional scope new variables are created, and those new variables are actually referring to the original objects which are being passed as arguments. However, because they are being created in the functional scope, so as the functional call concludes, those variables, those new variables are going to be destroyed. Now, if we make any changes in the new objects which are created within the functional scope, or let us say local namespace, then those changes will not be reflected in the parent scope. So, in the parent scope we might be passing certain objects as argument to the function, there will not be any changes, no changes would be reflected there, because they are in the parent scope, parent namespace, and whatever gets created within the local namespace within the functional scope, that is processed there, computations happen there, and it can be accessed there, and once the call terminates, then those objects are also destroyed. The same thing we are trying to display here. So, we are creating a function. So, def and then append underscore element. So, in this we are passing a list and the element that we want to append to that list, and again for that list we are calling the associated method, that is dot and then append, and we are passing element as the argument again. And to display this once this appending happens, we are printing this list, so that we will get to know that list is updated within the functional scope, the local variable is updated within the functional scope, and we can also print the value as well. And after once the call will happen to this function, and once in the parent scope we can make a call to this function, and there also we can print the variables defined in the parent scope and see how this is happening. So, let us first create this. So, here the definition would be created, and these two statements a list and element would be printed within the local when they were there in the local namespace of this function, and we are also making the call. So, all this will happen here. You can see in the a list we have 1 2 3 4 5, 5 has been added into the list, and then element is also printed, that is 5. Now, we are calling append element also, so that is V1 we are adding 5. So, because of this call, this printing happened, the previous printing happened. Let us look at what has happened in this V1. So, if we just run this, you can see this is also 1 2 3 4 5. However, if we want to access a list here and we run this, you can see we will get this name error, because a list was destroyed, it was created within the functional scope, and later on it was destroyed. So, we get this error that a list is not defined. Same is the case with element. If we run this again, so outside the functional scope this also does not exist, and you can see the error that is there, element is not defined. So, at this point we would like to stop here, and we will continue our discussion on Python in the next lecture. Thank you.